Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Wow, the semester's almost over. Isn't that sad? But you can always come back and watch me on YouTube. So I guess it's not that sad. All right, tonight I want to do a review for the final exam. And let's go to D2L. And you'll see there, the final exam will be this Monday, and you'll have until Tuesday to hand it in. And it will have relaxed 32 problems, 18 pages, like all the tests. Some of the problems are multiple part. There's no multiple choice. The points breakdown, 30 points general knowledge, 62 points nomenclature, 118 reactions. And you notice it adds up to 210 because there's 10, yes, 10 bonus points. I also broke down the points by the material covered in the different tests. 35 points are for test 1, 60 points test 2, 58 points test 3, 53 points test 4, new material 4 points, and once again it adds up to 210, 10, yes, 10 bonus points. Now, let me say something to get you relaxed, and that is, yes, it's a long test. It's the same, our final, same as 2 hourly exams put together. Historically, when I've done it face-to-face, and I've used similar finals, not the exact same one, usually students take about hour, 15 minutes, hour and a half to finish it. Now, out of 210 points, the class average, and I'm saying average, is usually 170 to 180. And that's an 85 to 90%. It's like getting an 85 or 90 average on an hourly exam, which means my students do well. Why do they do well? Because they've watched the videos I've done for each hourly exam reviews. They do use your hourly exams as practice problems. If you can do all the problems on the 4 hourly exams correctly, you're in good shape for the final. Now, what I like to do is just go through the 4 reviews somewhat quickly, because I'm not going to do a in-depth. I'd be here for 4 hours, and I don't think you're going to be here, and I'm not going to be here for 4 hours. But you can go back and look at some of the, at the end of the semester, where I go through over a couple hours. But tonight, I wanted to go through a couple things. But before I start, there are 2 things you should remember taking the final. The first one is how many bonds to carbon. I gotta get this finger fixed. How many bonds to carbon? 4. When I grade the final in the past, if a lot of students had looked at their answers, they'd say, that can't be right. There's 3 bonds to carbon. Or one time, someone had 6 bonds to carbon. It took me a couple minutes to stop laughing when I saw that. There's always 4 bonds to carbon. The other thing that will be your friend on the final, do you break carbon-carbon single bonds? No, except for combustion in my class, we haven't broken any carbon-carbon single bonds. Even at my level, breaking carbon-carbon single bonds is a very, very rare reaction. Now, carbon other atom bonds, sure, those are easy, like esters, and you've seen it this semester. Amides, you can do, those are easy, but you don't break carbon-carbon single bonds. All right, let's go through some of the reviews. Now, there's some definitions you should know. What's a saturated hydrocarbon? What's an unsaturated hydrocarbon? And you can go back and look at this. This is from test number 1 review. That's in the lecture section of D2L. Some of these you may have to click on the more button at the bottom of the page for that folder. All right. Now, we talked about the alkane names 1 through 10, and by now I know everybody knows those, like 4 is butane, 6 is hexane, etc. All right, by now, and I hope you know the different alkyl groups. What's a methyl group? What's an ethyl group? The 2 N-propyl isopropyl, and the 2 4-carbon are N-butyl and T-butyl. And we went through the IUPAC nomenclature on, don't forget, when you, I was talking about places I've been, and that's from I'm surprised it's still on here. Let me erase it. I worked in Gouda. Americans call that Gouda. It's the town in the Netherlands where I worked for a while. I worked for an international chemical company. I'd come to the Netherlands a couple times a year, like 4 times a year at least. But anyways, remember when you're naming it, you always number from the end of the chain. Now, here's a ring. And a ring, you count the number of carbons. This has 6. Hexane. And then, because it's a ring, you use cyclohexane. A lot of students over the years forget the cyclo. Don't. Remember every bend in a line. I only asked you to learn 3 rings, actually 4. Actually 3. I don't think I ever put on a test cyclopropane. So you don't have to know this one, even though I'm writing it down. I can't ever remember putting that on a test. But this one I have, this one I have, and this one too. All right. And remember, let's do a quick one. And if I were to ask you to give the IUPAC name for this, you look at that and find the longest chain, which I'll help you out, is this one right here. And if you count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's no name. And on no name, oh, it's our old friend, the methyl group and an ethyl group. Now, I'm not going to hold you to the IUPAC nomenclature alphabet rule, but I do hold me to it. So that would be ethyl, methyl. Then you'd start from the end that gives the alkyl groups the lowest number. In this case, it's here. It could have been from here if I wrote the structure. You have to check both ways. 2, 3, 4. Therefore, it's 4 ethyl, 2 methyl, no name. Remember, when you start using a chain, you always start from the ends. And real world, would I ask where would you find alkanes in your daily life? And the answer is yes, I did on test 1. And you can find it in natural gas, propane for your barbecue, gasoline, Vaseline, baby oil, and candles. And the only reaction I asked you for this chapter was alkanes, or cycloalkanes, combustion reaction with oxygen, you get CO2 plus water. Next, I talked about double bonds. Remember, double bond has one pi, one sigma bond. Alkyne, a triple bond, has two pi and one sigma. And I'll let you go how to name those. Don't forget about cis or trans. When you have both of these are butene, because drop the ANE, put ENE. You start from either end. The lead carbon double bond tells you 2-butene. But now we look at a plane right here. Notice two atoms, in this case hydrogen, are on the same side. That's cis 2-butene. When you have this plane and they're on opposite sides of that, it's trans. That's cis and trans with double bonds. In triple bonds, you can't. Here's some reactions. You break the pi bond, but not the single bond. Hydrogenation, hydrogen and catalyst break the pi bond, get this. Halogenation, you break the pi bond, get this. Now, when you add an unsymmetrical compound, one is H and the other is something else, you follow Markovnikov's rule. And the carbon of the double bond with the most hydrogens gets the hydrogen. The other one either gets the halogen in hydrohalogenation or hydrolysis. Use an acid catalyst. Think of water as HOH. One carbon gets H, the other gets OH. And just to remind you, double bond, HX, break the pi bond. One carbon gets H, the other gets X, follows Markovnikov's rule. Well, I was almost going to write this. I sort of did. I remember some students can't read cursive. That's sad. Now this has two hydrogens. This has one, which is greater. Hopefully I'll pick two. So this carbon gets the hydrogen. And remember, X can be chlorine, bromine, or iodine. In our case is chlorine. This gets the chlorine. There are 4 bonds to carbon. So you know how to put in the hydrogens. And that's how you do Markovnikov's rule. And for water, it's the same thing, except instead of HX, you have HOH. All right, triple bond has 2 pi bonds, and therefore you need more reactants. And chemists are lazy, organic chemists. So H2 bracket excess, close bracket means excess. You got all the hydrogen or whatever you're using to add and get that product. And here we break 2 pi bonds. Each carbon double bond, triple bond gets 2 hydrogens. And same thing with halogenation. All right, we talked about benzene, aromatic compounds, and toluene when there's a methyl group. The IUPAC, in their wisdom, took the ancient name and made it the IUPAC name. And I talked about ortho, meta, and para. Disubstituted, 1,2 disubstituted is ortho, 1,3 is meta, 1,4 is para. Some new substituents, chloro, fluoro, bromo, iodo, nitro. And here are the reactions: halogenation, nitration, sulfonation, and the Friedel-Crafts alkylation. Now, remember, since I didn't teach you about directors other than in the lab, these 4 reactions will always start with benzene. That's my gift to you, because there are more important things I wanted to spend time on. But one thing I want to point out, mistake I see on test 1, sometimes on the final, these 2 structures, and you could do another one with the bonds. The other resonance form is benzene. This is cyclohexane. Don't forget to put the bonds or the circle when you're doing benzene. Otherwise, I'm going to mark it wrong because it would be cyclohexane. And let me just remind you of one. And the question would be, what's the organic product or product you're following? By the way, I do have, I don't know how many, but maybe 6 or so, maybe a few more reactions where you have to do the starting materials, but you've done that all semester. All right, look for what's different, what's not carbon, what's not hydrogen, should get your attention always like that. And we have a benzene ring, carbon, carbon, ooh, halogen. That's an alkyl halide. Remember, R is anything with carbon and hydrogen. And we have aluminum trichloride, which can be this, and X can be, usually it's chlorine, but it could be bromine. And you make that rare thing, a carbon-carbon single bond. And the carbon with the halogen is the carbon bonded to the benzene ring. So we have our benzene ring. Don't forget to put the circular lines in there. And then do you break carbon-carbon single bonds? No. This is your R group. And that's the product you get. I'm going at a little faster speed. If you don't write it all down, I'll be posting this video later tonight, so you can go back and watch this. Am I nice or what? Don't answer that. And that was test number 1 review. All right, test 2 review. I talked about alcohols. Remember, an alcohol is carbons with a hydrox group on one of the carbons. Here's the nomenclature. Drop the E, add OL. Number for acyclic, for cyclic, no number. That carbon in the ring is always going to be number 1 when there are no other functional groups. Now, when you have a benzene ring with a hydroxyl, that's called phenol. I know some people call it phenol. Nah, phenol. And don't forget that. Common names, name the R group as an alkyl group and add the word alcohol. Remember, rubbing alcohol, you can buy anywhere from 70 to actually 90% isopropyl or 2-propanol and water. How do you make alcohols? Like this, and we went through that. Now, go back and learn Zaseff's rule. This is one of the ones where you get the double bond that has the most carbons attached directly to the carbons of the double bond. And I'm going to have they asked you to do that because in order for me to get through all 4 reviews before midnight, I'm going to move at a faster rate. All right. If you have an alcohol reactor with HX, you replace the OH group with a halogen. If you had a double bond, which I won't give you, you don't want to use HX, so you can use thionyl chloride, SOCl2, replace the hydroxyl group with a chlorine on the carbon with the hydroxyl group. If you have a primary alcohol, then the bracket here, this means oxidize. And primary alcohol, you make what you learn next chapter, 2 chapters, aldehyde, secondary ketone. I talked about thiols, which is the sulfur equivalent. They stink. That's the main ingredient in skunk, the defensive weapon. And you should know about remember about that awful tragedy in about 1935 in Texas, where a school blew up because of gas leak of natural gas, and they couldn't smell it. Why? Because it's odorless. Methane is odorless. And you should know, which I asked on test number 2, why does natural gas smell? Because they put a thiol, T-butylthiol, into the natural gas. All right, next I talked about ethers. And here, ethers are ROR prime. Don't forget, both test 2 and 3, we played that fun game, circle and name the functional group, 2 points each. Know how to do that, hint. And here, the only reaction I asked you to learn was Williamson ether synthesis, alkoxide, RO minus Na plus, alkyl halide, X can be chlorine, bromine, iodine, and you form an ether plus a salt. The oxygen bonds to the carbon and R prime with the halogen. The oxygen bonds to R prime with the carbon with the halogen. And next, I talked about an area I worked in the chemical industry, epoxides with ethylene oxide. I won't ask you to name the structure, but you should know these 2 reactions. Actually, there are a lot more, but this semester I have to limit what's important, so I just got to pick these 2. And there, alcohol, 1 molecule of ethylene oxide gives you this ether alcohol. When you have N molecules of ethylene oxide with an alcohol, you get this polyether alcohol. And both of these products right here, you can find in many commercial products, including this one and certain first skincare products. Then we got to the part that's near and dear to my heart. Dr. White loves aldehydes and ketones. Aldehyde, carbon double bond to oxygen with a hydrogen R group. Ketone, carbon double bond to oxygen with 2 R groups on it. And here I introduced you to prime. R prime and R double prime are just like in math that they use X, Y, and Z for variables. Aldehydes, find the longest chain with the carbon double bond to oxygen, which is called the carbonyl carbon. Drop the E, add Al, no number because the carbonyl carbon of an aldehyde is always number 1. Ketones, drop the E, add ONE. For acyclic, you need a number, and that's always going to be the lowest. For cyclic, no number, because the carbonyl carbon will always be number 1 in the ring of a ketone. I asked you to learn 2 common names that are important. Formaldehyde is the simplest aldehyde, and acetone is the simplest ketone. Nobody calls them by their IUPAC name. Now, if you notice it's in red, that means it's important. On test 2, and you should know, what is a carbonyl group? Carbonyl group, carbon double bonded to an oxygen atom. You should know how to draw it and how to describe it with words. And I asked that question on test 2. Now, how do you make aldehydes and ketones? Well, aldehyde oxidizes a primary alcohol. Remember, O in brackets means oxidizing agent. There are many of them, which I know, but my gift to you this semester, I didn't make you learn them all. Take a secondary alcohol and oxidize it, you get a ketone. And finally, Friedel-Crafts acylation. If you take a benzene ring, alcohol, acid chloride, that's what this is called, aluminum trichloride, you'll make an aromatic ketone. Remember, everything you see on the screen right now, I'm in test 2 review, and you can go to D2L and find this file. All right, now here are a series of reactions that students have trouble with sometimes on the final. So I would go back and practice these. If you take an aldehyde or ketone, that's what this means, react it with one molecule of an alcohol and acid catalyst, you'll get a hemiacetal or hemiketal. Remember, keep your eye on the carbonyl carbon, because that's where the fun is. Now, if you take 2 molecules of an alcohol and react it with an aldehyde or ketone, oops, it fell off. Hold on. You'll get an acetal or ketal. Now, I talked about a special case where the 2 alcohols are in the same molecule, and that's with ethylene glycol. And this is a way of putting a protecting group on a ketone or aldehyde that my advisor, Dr. Roosh, his PhD advisor, Dr. Stork, invented this. So I guess he's my grand advisor. Oh, that was awful. Sorry. But anyways, students always forget to put this bond between the 2 carbons. You don't break carbon-carbon single bonds. Now, something you learned later on, this goes on your stomach. If you take an hemiacetal or hemiketal, react it in water and acid, you get back the aldehyde or ketone you would have used to make that hemiacetal, hemiketal plus the alcohol. And again, I'm going at a fast rate, but you can go back and watch the video tonight or tomorrow or the next day. Again, students have trouble with this. I don't know why, but well, they're difficult reaction. If you take a ketal or acetal, acid and water, you get back the aldehyde or ketone plus the alcohol you would have used to make that. Now, if you look at both of these hydrolyses, what they have in common is they both have 2 oxygens single bonded to the same carbon. And this is the only place in all of organic chemistry where you'll see that. So if you see that and it's acid and water, you'll know you'll get an aldehyde or ketone plus an alcohol. All right, a fun reaction. Taking an alkyl halide plus magnesium, and you make a Grignard reagent. And why is this important? Because Victor Grignard won the Nobel Prize for developing these reactions. Once you make the Grignard reagent, if you're acting with an aldehyde or ketone, you do something special. You make a carbon-carbon single bond, very rare, very special. And let's take time out and do one of these. If we look at this, what's different? Ooh, oxygen to carbon with carbons on it. This is a ketone. And what do we have here? Carbon-carbon magnesium iodide. It's a Grignard reagent. Remember, X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to it? our prime and our double prime is still there. This becomes an alcohol, and you form a carbon-carbon single bond to the carbon that was the carbonyl carbon. And this is attached here to the carbon with the Grignard. So what's our prime? What's our double prime? What's our triple prime? So I have my carbon, our prime methyl, our double prime, hydroxyl group, and our triple prime is an ethyl. And in one step, you took a simple, that's the 3, a simple ketone and a simple Grignard, and you made a very complex alcohol. And that's the beauty of the Grignard reagent. By the way, this reaction, I'll never give a synthesis problem, but you will have to know how to give the products. All right, remember carbonyl, carbon-oxygen double bond, add hydrogen in a catalyst. You break the pi bond, each atom gets a hydrogen, you make an alcohol. Now, H.C. Brown found that if you another reagent, lithium aluminum hydride, LiAlH4, second step H plus in water, does the same thing, breaks the pi bond, each atom of the oxygen carbon double bond get a hydrogen, but this won't react with carbon-carbon double bonds the way this will, but I won't put that ever on test combined. And finally, another way of making a carbon-carbon single bond, that's the allyl condensation. Remember, the alpha carbon bonds to the carbonyl as acidic protons. You pull it off with base, and it forms an enolate anion, and it attacks the other carbonyl carbon to form a carbon-carbon single bond, and the second carbonyl becomes an alcohol. And that's why it's called Al for aldehyde, OL for alcohol, alvo. Oh, one thing I didn't mention, where do you find alcohols in your daily life? Well, drive by a gas station in Chicagoland, and you'll see this gasoline contains up to 10% ethanol. And not that I'm implying you should ever imbibe, but if you drink certain hard liquor or spirits, it has ethanol in it. My favorite vodka, but anyways. And if you look at rubbing alcohol, that has 2-propanol, isopropyl alcohol, and water. And finally, acetone is a ketone, nail polish remover. Would I ask, give an example of a product with a certain functional group in it? Yes. I've done that on test 2 and 3. All right, let's move on. Well, first of all, let me do this. To test 3 review. And test 3, we start out with a carboxylic acid. You name them by dropping the E, add the letters OIC in the word acid, and it can't be in a ring, and the carbonyl carbon is always 1. 3 common names, or actually 2 common names, one that's both a common IUPAC, 1 carbon acetic acid, that in water is called vinegar, formic acid, simplest carboxylic acid, and when R is a benzene ring, that's called benzoic acid. Now, these carboxylic acids are called acids because in chemistry, an acid is a proton donor. So if you take a carboxylic acid, react it with base, and the base I used for this semester was the simple hydroxides, where M is either lithium, sodium, or potassium, and you get this carboxylate anion. I always show the charges. I think it looks cool. See, I'm a cool organic chemist, but you don't have to. Now, one special one was you take a carboxylic acid, react it with sodium bicarbonate, baking powder, you get the carboxylate anion, and the carbonic acid that's formed from this reaction immediately breaks down to water and carbon dioxide, which is given off as a gas. Remember the little rocket ship story I told? My father taught me how to do that. These little plastic tube rockets that would boom. I can still picture that. The other thing, remember I taught you tomatoes have citric acid. And if you're making the best tomato spaghetti sauce, at the end, put in a little baking powder, and that reacts in this reaction to neutralize some of the acid, the citric acid, to make it smoother. Also, put in a pinch of cinnamon if you got a real big pot. I had a friend who put a whole tablespoon in a small pot, and all he could taste was cinnamon. No tomatoes, period. Don't do that. All right. Now, if you oxidize very strongly a primary alcohol, you'll get a carboxylic acid. If you oxidize an aldehyde, you'll get a carboxylic acid. One of my favorite, and I've done this reaction for research when I was getting my PhD, take a Grignard CO2, second step acid and water, you get a carboxylic acid that's one carbon longer than the R group you started, because you add this carbon here is this carbon here. Next, I talked about esters. And esters have this, and there's IUPAC way, which is name the R prime as the alkyl group it is in the front, then name the carboxylic acid used to make that ester. Think of R prime as H, that's the carboxylic acid. Drop the IC in the word acid and add ATE. Now, I had a very sharp Chem 170 student many years ago said, well, I know a better way. And for 95% of the time, except when R is benzene, this works. Name the alkane from the longest chain, including the carbonyl carbon in this part of the ester as an alkane. And you drop the E and add OATE. All right. Now there's one ester you should know the common name also, and that's ethyl acetate. Nobody calls that ethyl ethanoate, it's ethyl acetate. And that's one of the two molecules used as nail polish remover. The other one is acetone. Now, carboxylate anions, which have this structure, you name the same way as an ester. However, instead of R prime in front, you name M plus as the element it comes from. If it was Na plus, it would be sodium and lithium or potassium. All right, then the rest of it, 2A and B, you name the same way. Now, I don't know if you've been out walking, now is for at least a day or two, it's starting to get warm out there, even though next couple of days is going to get cold again. It'll get warm again eventually. If you smell flowers, or if you taste or smell many fruits or vegetables, an ester is responsible for that. How do you make an ester? Fischer esterification, carboxylic acid, alcohol, acid catalyst, ester. Now, reactions of esters. If you take an ester, react it with an acid and water, and this is how you break down fats and oils, you get back the carboxylic acid and the alcohol you would have used to make that ester. Now, if you use a base hydrolysis, the carboxylic acid you make here immediately reacts with the base to form the carboxylate anion, so you'll never see the carboxylic acid. The fastest reaction and one of the fastest reactions in all of chemistry is an acid-base reaction. Now, you know I love Grignards, and here we have the reaction of an ester with two molecules of a Grignard, second step acid, and water. You get two products. One is where you've made not one, but two carbon-carbon single bonds to form this alcohol, and the OR prime becomes this alcohol. Let's take a look at it. Let's have some fun. And the question would be, and I'd be nice on a test or on the final, like I did in the test, you see a plus there that tells you got to get two things. When I took it as a chem major, our professor didn't do that. You have to know that. Am I a nice guy or what? Don't answer that. All right, look for what's different. What functional group is here? Ester. Ooh, carbon, 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 magnesium iodide. That's a Grignard, and there are two of them. Member X can be chlorine, bromine, or in our case, iodine. Second step, acid and water. And you get, keep your eye on the carbonyl carbon, the R group is still attached to it, becomes an alcohol, and the two ester R triple, not ester, Grignard, is bonded to that carbon. And then this part right here becomes an alcohol too. And you usually have that a low molecular weight so you can distill it off and get this higher alcohol here. Well, this is R prime, and this is my R triple prime. So I have my carbon from the carbonyl. It will have R, it will have an alcohol, and then my two R triple prime. The carbon with the magnesium iodide is the carbon, this carbon is bonded to in the R triple prime. And then this part here gives me this alcohol. And that's how you have fun with Grignards and esters. All right, next I talked about amines. Amines are where you have nitrogen with alkyl groups on it, primary, secondary, tertiary amine. Remember in the amines, nitrogen has 3 bonds to it. And I only asked you to learn the common names. They name each R group as the alkyl group it is in the front and add the word amine. Now, there's one special amine, aniline, when R is a benzene ring. Then something very near and dear to my heart, quaternary ammonium salts. And that's used as antimicrobial compounds. I told you a story about my mouthwash. It keeps my gums nice and healthy because it has a quaternary ammonium salt. And an area I worked in heavily, I have 6 patents, US patents, and that's quaternary ammonium salts as fabric softener. Now, to name a quaternary ammonium salt, the common name each R group as the alkyl group it is, add the term at the end, ammonium halide, where if X is bromine, it's bromide, chlorine, chloride, iodide, iodide, iodine, iodide. Now, amine salts are named this the same way as quaternary ammonium salts, except you only have 3 or less groups. Remember, R prime and R double prime can be hydrogen. All right, how do you make an amine? Alkyl halide ammonium base, primary amine. The nitrogen bonds to the carbon with the halogen. You take a primary amine, alkyl halide and base, you'll make a secondary amine. Remember, X can be chlorine, bromine, or iodine. You take a secondary amine and react it with alkyl halide and base, you'll make a tertiary amine. And finally, oops, not yet, finally, if you have a nitrile, which is a carbon nitrogen triple bond, add hydrogen excess in a catalyst, you break the two by bonds, and each atom of that triple bond gets two hydrogens, and it's a great way of making a primary amine. And that's the first reaction I was asked to do research on when I joined the chemical industry a long, long time ago in a galaxy far, far away. All right, now what was really near and dear to my heart is this reaction. Take a tertiary amine, react it with alkyl halide, and you'll make a quaternary ammonium salt. And that reaction helped pay for a number of cars, my mortgage, got me around the world because I'm an expert in that. Now, amines are bases. So if you add an acid, you'll have a proton transfer to make an amine salt. Now remember, amine R and R prime and R double prime, one, both, or none can be hydrogen. Next, I talked about amides, and amides are a carbonyl with an R group and a nitrogen with two R groups on it, but R prime and R double prime can also be hydrogen. How do you make an amide? Take a carboxylic acid, react it with either one R prime and R double prime, RH, ammonia, or a primary secondary amine, and you form an amide. Now, as you learned later on, amides are the linkage that hold amino acids together. So an important reaction, if you take an amide and react it with HCl, which is in your stomach, and water, you get back the carboxylic acid. However, the amine, being a base, reacts with the acid, and you get the amine salt of the amine you would have used to make that amide. Now, if you react the amide with base and water, the carboxylic acid will react with the base to get the carboxylate anion of the carboxylic acid you would have used to make that amide, but you'd also get the amine. Now, the only thing I asked about heterocyclic compounds, you should know they're a ring with carbon and other atoms, such as nitrogen or oxygen. And the only one I asked you to learn was pyridine. I'm going to take a 30-second voice break. Actually, I don't need 30 seconds. And test 4, which you just did, you should know what a polymer is. You should know what's an addition and a condensation polymer and examples of such. What's the thermoplastic polymer and thermoset and examples of such. And remember, like I asked in test 4, what's the key functional group in a saponifiable lipid, otherwise known as a fat and oil? And that's an ester. Now, what's the difference between fats and oils? Fat is a solid or semi-solid at room temperature. An oil is a triglyceride at room temperature. Remember, this is an ester, so a triglyceride, a fat or oil, has this general structure. And as you learn, you can have acid hydrolysis of a fat or oil, and each of these three esters undergoes this reaction. You learn for test 3. Same thing with base. You get the alcohol plus the carboxylate anion. In this case, the alcohols are all together in glycerin. Same thing up there. Now, new reaction, sort of, is there's 2 ways of catalyzing something. One, by using certain chemicals. The other is by heating up a reaction. And if you use steam, which is hot water, it's the same as acid hydrolysis, except you don't use the acid. And I worked for a company where I was the lab manager, and we were on our plant site where I worked. We did this reaction about 2 to 3 million pounds of fat per week. Yep, per week. And you get the same product, a glycerin and these fatty acids. Now, I asked you to learn two structures of only two fatty acids. Stearic acid, which nobody uses the IUPAC name, has 18 carbons, and you notice it's a saturated fatty acid, only carbon-carbon single bonds. Oleic acid has 18 carbons also, but a double bond at carbon 9, C9. Now, if saturated fat only has carbon-carbon single bonds, unsaturated fat has at least one carbon-carbon double bond. By the way, Mother Nature never did triple bonds. Organic chemists came up with that. Next, I asked you to learn tallow is beef fat, yellow grease is pig's fat, white grease is pig's fat. And I showed you for the designation for tallow, yellow grease, white grease, use this where one is a sterile group, oleal, arcebo, and another sterile. And if I were to ask you what's the product, which I did on test number 4, tallow plus sodium hydroxide and water, you get 3 different products. What I'm really asking is, here's what is generalization of tallow, base and water. Here's the saponification of an ester. You get each one of these gives you an alcohol, glycerin. This ester gives you this carboxylate anion, sodium stearate. This gives you this one, sodium oleate. And here we have sodium stearate again. All right, one of the important things you should know, leaving my class this semester, how does soap work? You should know the structure of soap. Non-polar tail, polar head. Water is polar. Dirt and grease are non-polar. The key to this is light dissolves light. The dirt molecule, being non-polar, attracts the non-polar tail of soap. The polar head stays on the outside, far away from that. And this forms a micelle, which you should know. And now the micelle looks polar to water, and the water says to the micelle, I'm polar, you're polar, and they go down the drain together, and they do. And that's how you get clean. You should know the ring skeleton of a steroid, 6, 6, 6, 5. Talked about carbohydrates, carbohydrate, polyhydroxyaldehyde or ketone, or molecule upon that hydrolysis becomes a polyhydroxyaldehyde or ketone. On test 4, I asked what's chirality or chiral. That means handedness. And you should know an achiral object is one with a superimposable mirror image. A chiral object is an object with non-superimposable mirror image. If you see in the name right or left, that immediately tells you it's chiral. Like my right hand is chiral, so is my left hand. And then I talked about chiral carbons. And a chiral carbon is a carbon atom with 4 different groups, 4 different atoms, or a combination of 4 different groups or atoms. Then we talked about an enantiomer, and that's the non-superimposable mirror image of a molecule. If you remember on test 4, I asked you to draw the enantiomers of a couple of molecules, and that means draw the mirror image. Now, I showed you 2 reactions where they were intramolecular reactions. They happen inside the molecule. You have an alcohol here and glucose, and the aldehyde, forms a hemiacetal when it's intermolecular between 2 separate, you need acid catalyst, but when it's intra, you don't. This attacks that, forms this cyclic hemiacetal. Same thing happens with fructose, but here we have a ketone, the same hydroxy group on C5. You form this hemiketal. Now, a reaction is a slight wrinkle on a reaction I taught you for test 2. If you take a hemiacetal and now react it with a separate alcohol and acid, you replace this alcohol with this, and so in glucoside, this cyclic form, you replace the OH with OR from the alcohol. And that's the basis to bring glucose molecules together to form starch. And sucrose is this fructose and glucose bond together. I asked that on test 2, not test 2, test 4. Starch are a lot of glucose molecules together. So what that tells you is if you take glucose and acid catalyst, which is also called an enzyme, you make starch, the good stuff like French fries, potatoes, rice, pizza, crust, all the things I can't have now. But anyways, since sucrose is fructose and glucose linked together, acid and water, like in your stomach, break them back down to fructose and glucose. Starch, like the acid in your stomach and water, reacts with the acid and water to give glucose, which is the sugar in your blood. All right, listen carefully. Leaving my class, you should know how to describe with words in a chemical reaction, general chemical reaction, what happens in your stomach when you eat a fat or oil. And, oh, by the way, Abigail, say hello to whoever's behind you from Dr. White. By the way, when I've taught, I've had mothers with their kids on their lap or people where their cats and dogs show up. It's allowed. All right. You should know that when you eat a fat or oil, that's acid hydrolysis of an ester. And here's the general reaction you learned for test number 3. When you eat a carbohydrate, that's acid hydrolysis of an acetal. And here's the general reaction. Now, there's a third reaction I'm going to talk about right now, so I really don't have it as a review because this is new material that I talked about after test 4. And this is an amino acid. And that's short for amino or amine carboxylic acid, was shortened to amino acid. And always you have the NH2 group on the alpha carbon, carbon bonded to the carboxylic acid carbonyl carbon. And when R is not hydrogen, anything else, that alpha carbon will have 4 different groups and will be chiral. I'll say that again in slow motion. When R is not H, it can be, it's called glycine, I think. But when R is not H, anything else, methyl and a whole lot of other things, that alpha carbon has 4 different groups, which makes it chiral. Now, amino acids can react with themselves to form proteins. And proteins are just the link in a protein. I can spell it right. Did I tell you I was always the first one down in the spelling bee? The link in between the amino acids, what holds amino acids together, is an amide bond. The key functional group in a protein is an amide. And therefore, leaving my class, you should also know how to describe with words and a general reaction what happens when you eat something with protein in it. How to describe it with words? Well, it's acid hydrolysis of an amide. And the general reaction, which you learned for test 3, in your stomach is hydrochloric acid. That's a wonder why that we all have cells that make hydrochloric acid, HCl, and water. And you get back the carboxylic acid you would have used to make that amide, but because you're an acid, the amine becomes the amine salt. And in an amino acid, they're connected together. So you should know when you eat a protein, leaving my class, how to describe with words in a general reaction. That's acid hydrolysis of an amide. And there's a general reaction. You should also know, leaving my class, how to describe with words and a general reaction what happens when you eat a fat or oil. And that's acid hydrolysis of an ester. And here's that reaction. You should also know how to describe with general words and a general reaction what happens when you eat a carbohydrate. That's acid hydrolysis of an acetal, and here's the general reaction for that. Now, if you go back and look at the original first introductory video, I said, my world of organic chemistry is your world of organic chemistry. You just don't know about it. But now I can say with confidence, my world of organic chemistry is your world of organic chemistry, and you know about it. You're now one of the few people on the planet or in our country who knows organic chemistry, which is a good thing. But then I'm an organic chemist and I'm quite biased toward it. And with that, I'm done for today, other than I will ask a special request. If you like what I did this semester, please go to ratemyprofessor.com and let people know what I did. If you didn't like what I did, go and warn them, stay away from this guy. No, I don't think you should, but I think I do a good job, and I hope you do too. And with that, I'll say, gehen gesund. Goodbye now.
Thank you.
Welcome. Bye now.
Bye.
From Granny to Beverly Hillbillies.
Bye.